My name is Hinojosa. We're going to talk about testing legacy code and refactoring patterns, one of my favorites. I don't have a beard anymore just because I submitted this picture to Microsoft's. I don't know if you ever remembered Microsoft's Guess Your Age. I submitted this picture and it was off by like 10 years. I mean, in the positive side, so it aged me quite a bit there. Anyway, so I'm going to discuss some techniques to get around some undesirable code while preserving signatures. And that's going to be important because you want to keep those interfaces intact, and that's the idea for this agenda. I'm going to keep it Java-centric as well, so that's since we're mostly a Java-based conference. I'm going to start off with this image here, and I know I'm probably aging myself with this particular slide. And this is a picture of a TV show called MASH, which went from 1973 to 1982. The idea for MASH was a wonderful show. It was mostly a comedy. When it wasn't a comedy, it was one of the best dramas that you would ever see on TV. But the idea for MASH was, people who got injured during the Korean War would be brought into this mobile army surgical hospital where they would get patched up. And what they underwent was meatball surgery is what they called it, just because there were a long line of injured, so they had to do their best to, patch them up and send them over to Tokyo General. The reason I brought this picture up is that that's what I consider, adding a change to your code base. Particularly when dealing with legacy code. You can't spend, that, great of a time. You should put some time, of course, and do testing and things like that. But sometimes you got to be quick about it. And so a lot of this I took from this book here, which happened to be #1 on a poll a long time ago on Stack Overflow. But this happened to be the #1 book, Working Effectively with Legacy Code by Michael Feathers. Point in fact, though, this came out in 2004, I think 2004. So it's aged quite a bit. I mean, it's still great content. It's still a great book. But since then, we have Lambdas and we have like really nice IDEs now. So, how we go about doing these has, dramatically changed. One of the places that I cite all the time, and a good way to review things, is the Guide to Testable Code. I don't know if you've ever seen this before. This is from Misko Hevery, and Misko Hevery is formerly of Google Testing. I think he's still with Google, but he was part of the testing at Google. And he wrote this quite a while ago, but I think that's absolutely great. Guide to Testable Code. And he has really 4 main chapters here on writing testable code and some of the warning signs here, like new keyword in a constructor at a field declaration, static method calls in a constructor, right? Things that are smells and that are just really upset you when you take a look at code. Flaw number 2, digging into collaborators. You've probably seen this in your code, right? Have an object, dot, call that, dot, call that, dot, call that, dot, 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 right? And you're walking that chain, or you have suspicious names like, hey, what's the name of this class? Manager. Okay, great. What does it do? Yes, right? And you've seen those classes before. So suspicious names like that. Brittle global state, and how do you deal with singletons? So I'm not going to delve too much into this. Although I would like to, but take a look at this one, singletons, right? The main part, it's a great design pattern for a good 25% of the time, I guess. It's great if you need a single instance, but if you design a actual singleton, it's really hard to test. If you design it wrong, then it's not really thread safe if you don't add like a synchronizer or a lock to it. So there are a couple of things with singletons. But as far as testability goes, it is really hard to test. And the class does too much, right? That's the manager style class. And if you have to sum up what the class does and includes the word and, then you're violating something, right? And we call this one single responsibility principle. Your class should do one thing and do one thing really well. And there's only one place that you need to change it. Which means that if there's a bug somewhere, you know where to go, right? And that's a good feeling. If you have to fix something. If you have to change a feature in your software, or if you need to add a feature to your software, and you need to go to 3, 4, 5 different places, might be something wrong. Could be just fine, but it could be a sign that things are going wrong. Anyway, that's what that's for. So I'm going to do a little Elmer Fudd here, be very, very quiet. And the thing that we want to try to avoid, and again, this is very much like surgery, and that's why I had brought up MASH. And the idea here is that when you perform this surgery, you want to make sure that the interfaces stay intact. If I change this bar from like an int to a string, I don't know if you can see that there on the right-hand side, right? I'm changing the type, I'm changing the structure, I'm changing the interface of it. And if I do change that particular interface, then guess what? Everything else breaks, everything else breaks. And now you're just chasing something and making it hard for others as well. So the thing that we want to do is we want to maintain that particular interface. And so before we begin, we still want to do test-driven development, but you're like, yo, hey, this is a brownfield project. Things have already been developed. How could I do TDD? Well, TDD can be applied in brownfield projects. You could do this while you're adding new features to your particular software. That's a great thing, and you could do that after the fact. It doesn't have to be before you're designing software. So general reminder of what TDD is, quickly add a test. Run all the tests to see a new one fail, okay? Make sure you fail, right? You want to add a failure to it for those that may have not been quite as seasoned in TDD. You want to make sure you're doing and adding something of consequence, right? That's what the red bar means. Because think about it, like if you create a calculator adding 2 numbers, you could go on with 1 billion tests, right? And all you really need to do is test like really a 1 + 1 or a 1 + 2, but you don't have to go all the way through. There are, some other tests that would be of a consequence, which would generate a red bar test. So again, you don't have to create like 1 billion green bar tests. All you have to do is create a test of a consequence and make sure it fails. That's what that's there for. Make a little change, run all the tests to see them succeed. And once you have everything green bar, make sure you have that state next. Then you could go in and refactor and remove duplication. When you can't think, oh, here's a good one here. When you can't think of any more red bar tests, remember the red bar test is your consequence, right? You're adding something of consequence. You're kind of giving your code a hard job to do. And when you can't think of any more of those red bar tests or those fail tests, then you must be done, or you might be done. There are some other tools that you could do to really aggressively test thereafter, but that's the general idea of what TDD is. What are some things that we want to work towards, right? Single responsibility principle throughout your entire system. If there is something that needs to be fixed, if something needs to be changed, you need to know where it is, because you have a class that has a single responsibility throughout the entire system. That's something you would like to do. Least cost substitution principle is something to where you subclass a particular class and you override a particular method. You should not add any extra surprises on that. Like if you just decided, hey, I'm going to throw a exception that wasn't necessarily a part of the superclass contract, then you're kind of like violating that principle from that superclass, right? Those are some things we want to look out for. We want methods to have like a command or query responsibility, right? If a method is a command, leave it as a command. Don't have it be both a command and query. Now, commands can return something materialized from that command. Let's say like you have a method that's going to return an ID. That's not necessarily you querying an ID. That's just a remnant of you issuing a command. But a query is something, get me all the employees, for example. Method should be either a command or a query, not both. Command is a method that modifies the state, and query is a method that returns the value, but doesn't necessarily modify that particular object, okay? So, and we can kind of see the reason for that. Makes things a little bit more reasonable in order to do it, and methods should be responsible for one thing. The other one I think is a really important one that we want to adhere to is the open-close principle. Open-close principle is software entities, like your classes, modules, functions, should be open for extension but closed for modification. This one is sometimes a little bit puzzling, I think, when you first hear it. But the idea for this is, and I think it ties very well into TDD, is that you use TDD to design your classes. And you put a lot of effort into it. Now, do you want to just go in there and just rip it apart every time, someone wants to do a change, or maybe you want to do a change? Not necessarily. You have a chance to breathe a little bit and think about it. And one of the things that you could do is that you have plenty of design patterns that you can decide to add around that to affect any other kind of change, right? Leave the core alone, but there are opportunities to use, say, like the adapter pattern, the decorator pattern. You can get a return value on that, use some functional programming to mutate and change that. And I say mutating in a good way, right? And you could change the behavior of all that thereafter, right? So you don't necessarily have to say, I got to do a change, start breaking apart the code and start messing around with it. And that's the idea for this. Keep it closed for modification. You may have to modify it. That may be okay, but again, give it a chance to think about it. But really, there are other opportunities, and that would be through extension. Boom. All right, let's talk about some techniques. So there are some great mocking frameworks out there. And I'm not a fan of mocking. Although I do use it, I try to keep it at a minimum. And that's one of the other things about this particular talk. There are things like PowerMock. Mockito has ways that you can get around some of the more harder ways to do any kind of mocking. But again, I'm not a big fan of those. One of the smells that I believe there are, and I don't know if you see this in your testing code, when a mock returns a mock, and then you add that behavior on there. And it's all within one test. And then all of a sudden you have these beasts of tests, and you get someone new in to try to review those tests and try to maintain those tests. Well, if you got a lot of setup for these particular mocks, that's a little bit of a heartache there in order to manage those. So that's really one of the big reasons why I'm not a fan of mocking frameworks. But they're useful, they're needed, I use it. And the times that I do use it is because I want to do, let's say multiple, I want to mock behaviors for multiple methods. If that's the case, then I'll use a mock. But if I need to mock like a single method, I'll use a lambda instead, and that's the way that I could avoid that. All right, I'm just gonna skip that one because I've kind of described that. All right, well, let's talk about some patterns. Let's start here with extract delegate or class. Ooh, interesting. You ready for this one? All right. What we're looking at here on this particular slide is public class person with name, area code, and number, and I have get phone string. Now, what's wrong with this? On the left-hand side, I have name, I have area code, and I have number. This is called a primitive obsession code smell. The primitive obsession code smell is person is in control of area code and number, okay? So if I ask Scott, just like, what's your area code and number, him as a person doesn't have an area code and number. I mean, it's understood that you have a telephone number, but really as far as object orientation goes, this shouldn't be responsible for it, right? There should be a phone number, which is what's on the right-hand side. So extract delegate is, let's take those members and make a delegate for that, and that's what we see over here on the right-hand side. So create the attributes that are needed. Again, area code and phone number should really be a part of the class phone number. They shouldn't be a part of the person. Nothing wrong with duplication and I love duplication, right? I get the dry principle, but that should be the final product, right? The don't repeat yourself. But during the course of refactoring, duplicate all you want. And in fact, that's one of my favorite strategies when doing refactoring. Copy, copy, copy. So I'll have area code there, I'll have number there, and then I have my get phone string here. Then what I could do is I can put getters in here. Now, some of you are going to be like, getters, right? Just because we're heading more into a more non-getter, more non-setter, and just use accessors and mutators in order to get that. But I'll tell you why we have that, because we have the area code there, and what we want to do is we kind of reference that in. This reminds me of, rope or yarn where we're tying something over there, and then when we're ready, we're just going to reel that in and bring that over to the new class. And that's kind of what we're going to be doing there. So what we could do then is inject that phone number, as you see right over here in the person, and use that phone number and get area code. See where that, it kind of looks like a rope that I'm tying in over here, right? Tie that in. I have the phone number there. I have the get area code. And I'm going to start to get rid of those two, the area code and number, because the ownership now is over on that phone number, and I can, right? Once I have that then, I have that get phone string here, which I may want to migrate over as well. Because what we see here on the left-hand side, this one's called feature envy. Feature envy is like having public class bank account, public int balance, right? What's wrong with that? Yeah. You're like opening the bank's balance to have anyone do whatever they want. Well, I'm just going to put $1 billion in there, right? With no checks or validation. So that's kind of what's happening here, is that I have that get area code and get number, and I'm getting it direct from that particular phone number. So how about, because I see this, because I have that feature envy there, why don't I move that one over, okay? So I could extract methods for this, and so I have that get phone string here, and I could move everything over if I need to, okay? And migrate everything over. I could inline, clean things up, and then delete the getters once I have everything as part of tying things up, and so, I have everything in its place, okay? You may have a man in the middle, but do some refactoring afterwards on how things would make sense, okay? You've definitely lightened the load, smaller testing, and that's one of the big parts about this. Now I have a person. If I need to do a test on person, I go to person. If I have a test on phone number, I go to the phone number. Beautiful, okay? And I could do stuff like this as well, where I have the phone number and all the formatting is there over on the phone number side. Cool. Let's take a look over here in IntelliJ and see how you could actually do this. This one is a blackjack game that Ted Young developed. I like this one because it's only like 3 classes. Here's card, here's deck, here's game. This is the blackjack game here. What's great about this one is that this one has any UI as well. So it's a mixture of things where you have the opportunity to split things up and put things wherever they need be. So we have some UI, we have some domain code, and things are a little bit all over the place, right? And so over here, we kind of see that mixture of domain and UI, which is, here's a while loop, which is part of the domain. Here's the game state, that's UI. Players making a player choice of whether to stand or hold. That's a little bit of UI. So we got a mixture all over the place. I have this one here for wallet, which is my little thing that I want to use here a little bit later. But on this game here, let's take a look at this one. Game has these two right over here, dealer hand, and it has player hand. You see that there? This is a primitive obsession. But you're like, yo, that's a list. How could that be primitive? Well, it is a collection. It's not a primitive like in Java speak, but it is a primitive because this thing could be inside of a rich object, right? So what I want to do is I want to do the following. IntelliJ people here? Okay, good number. So on here, I'm going to do a Control-T or a Control-Alt-Shift-T. Sorry for Windows users, you're going to have to use all your fingers and take off one sock and put that on the keyboard as well. Control-T is the refactor this. Okay, wonderful little pop-up that comes up here. And the one I'm going to do is extract delegate. Okay, I think you'll love this maneuver. I'm going to select extract delegate. And here's the name for the class. Now this one's a dealer hand, which is a list of cards, but I want to wrap around that because I think there should be a rich object called hand. There it is. Here, let me highlight that. Here's hand. What I'm going to do is I'm going to generate accessors so that way I can access the cards. okay? And so there it is. I'm going to do a refactor, and sorry for the disgusting analogy here, but this is very much like picking up after your dog, right? How do you pick up after your dog, right? Do you do this? Pick up the stuff and throw it in the bag? I used to do that for months. No, I'm just kidding. I never did that. But, you know, you wrap the bag and do that, right? That's what's happening here, is that I'm wrapping around that primitive variable and I'm doing this, right? And then all of a sudden, whoop, there it goes. What we see over here is that I now have a hand. Cool, right? This, I'm going to do a Shift F6 here, and right over here, I'm going to do dealer hand. Okay? Well, now what? Well, let me come over here. Let me clean things up a bit here. This should really be called cards or card lists. Call it cards. And this one over here, I'll rename this one called get cards. There it is. And there's a hand. Isn't that pretty nifty? Right? Now here's the fun part. Now what I want to do is I'm going to do a Command B here, or I think a Control B. And what we see here is I'm going to go on the hunt. And the hunt is, let's go find out where get cards is being used. Because my goal in all this now is the following. Get rid of this method, right? Because that's a feature envy. I don't want to give them the cards. If you need to do anything with the cards in my hand, you'd have to ask first, right? In poker, you got to pay at the end of the game to view someone's hand in poker, right? Same sort of thing here. We kind of want to limit that access. So I would go on the hunt right over here. Let me show like a little example of this, of some of the things that we could do to refactor. One of the things that you'll notice here is that I have comments within the method. Comments outside the method are great. Comments inside the method reveal that these could just be potentially methods on their own. But take a look at this one right over here. I have dealer hand, get cards, add, deck draw, right? Here's that dealer hand where I kind of want to clean things up a bit. So how about I do this? Dealer hand, let's see here. How about I do dealer hand, let's try that one. Dealer hand, deal from deck. Okay. Oh, in fact, how about I do this? This would be fun here as well, because I have two of these here. So how about I create a method out of those, and I'll call that one deal from. That one looks a little bit better. And so I'll replace that, and I'll replace that. Okay, there it is. Let me go to this deal from here. Great. And what I want to do is I'm going to do this refactor here, and I'm going to introduce a parameter called deck1. Okay? So I have this deal from deck, right, with that particular dealer hand here. Now what I'm going to do is I'm going to hit a F6 here. And the way to look at this is the following. Deal from deck, who is this going to be applied to? And so I'm just going to focus on this area over here. I want to move this method over to dealer hand, and away we go. Okay? Now this should look a little bit better. And so I'll have this here. Let me do some cleanup here. I will safely remove game. I have the deck coming in. I will rename that to just regular deck here. I have deck draw. And why don't I do this? Let me do an inline. And this inline here, I want to keep the method because I still want get cards there. So I'll keep the method, and that's the way it looks. So now hand, I have access to the cards internally here where it should be. I have a rich method called deal from. And the way that it looks over here is, you know, from this point of view here, this one says dealer hand, or dealer hand, deal from deck, right? And so I continue going on the hunt, continue going on the hunt, continue going on the hunt, till inevitably what should happen here is that this right here, this get cards, should be gone. Because what you did is you found all the methods that had to do with a hand, and now you're putting things in their rightful place. Okay? And that's that maneuver. What do you think about that one? Pretty cool. cool, right? All right, groovy. Extract interface. So extract interface is you want to, let's say, create a different implementation. That's great. That's where the extract interface comes in. So what you could do is, just create something called interface. If you're doing it manually, create an I account. I know .NET users kind of do this all the time. You don't have to, because we have outstanding IDEs to do all that. And so this would implement that particular interface. And so what you could do is just bring in those methods that you wish to use for that particular interface. And so, bring that in. Once you have that, then you can add whatever kind of behaviors for that particular interface. So if I have a bank account and I could extract the interface for deposits and withdrawal, then I could have a savings account, and I could have a retirement account, and I could have different kinds of accounts. So every account would have this behavior. Now, what's important about this? When you have to make a change, you don't have to panic and change existing code. It's not like hard drives are going to run out of space quite as much anymore, right? You still have room. Create a different implementation now based on this interface. And that way you can just swap it. And what's great about this technique is that if you want to apply any kind of benchmarks to it, go ahead, right? You have two implementations, and they both share that same interface. Another consideration is with databases, right? If you have a class that represents how you store things onto a database, extract the interface and create another representation for an in-memory database or anything else to represent that particular repository. A lot of great uses for the extract interface. Let's show you that one. And I don't know if you've ever seen this one before. Again, Control-T or Control-Alt-Shift-T is the way to go on this one. So here, let me highlight that one. And here we go, Control-T. There it is. And we have extract interface. So really the cool thing about this one is we have extract interface, but what we could do is we could rename the original class. I like this one a lot. I think this is a great feature of IntelliJ. What we could do is rename the original class and use the interface where possible. So I want to rename this one here. How about rename that one Token Wallet, and where we can add funds, spend funds, and ask whether it's empty, right? And that's the idea for a wallet. And so I'll do a refactor on this, and it will do all that for you, right? And here it is. Here's Token Wallet, which just deals with integers in this particular case. I could make it generic if I wanted to as well. So once I've extracted that interface, but I just want to show you what this interface looks like, right? And that's the extract interface. But again, if I wanted to, I could say, hey, let's make this one T to where we could spend the amount, and we could also add funds to it. Now this one's going to say, hey, you broke me right over here, because then I could say, hey, this is a wallet of, type integer here, okay? But these would just have to change a little bit, and I'll go ahead and make those changes. There's integer, and here's integer, okay? So not too bad, right? And that's extracting the interface. If now I want to create, there it is. If I now want to create a different kind of wallet, one for US dollars, or one for pesos, or one for Canadian dollars, or euros, or whatever, chips, or whatever, I have that genericized, right? So again, changes, you don't have to break things, right? You don't have to modify things on a class. If it works well and you tested it well, leave it alone. Create a different implementation. Pit them against one another. Do benchmarks against one another. Maybe your original was a lot better than the new one. You prove it, right? You have the numbers for that. So extract interface, extremely, extremely valuable. All right. Parameterized method. Here we go. So duplication is going to be the name of the game again. Everybody's reliant on bar, right? There is code that's referencing bar. I don't want to mess with it. I want to do refactoring. A way that I like to describe refactoring is I'm not changing the windows. I'm not changing the doors to my house. I'm just moving the furniture around. So, the maneuver for this is duplicate. Whew. Again, extremely powerful concept. Duplicate your code for refactoring. And that's your surgery, right? You're being a surgeon with code that already exists. Now, oh, by the way, what's the problem with this new bar here? Should I use Mockito or should I use PowerMock to mock away that new instantiation? Some of you are like, hell yeah, right? But there's a cost to mocking. And again, nothing wrong with mocking. I call mocking an ambulance, right? Ambulances are great, right? They're like mobile hospitals and, they're amazing, right? But if one's in front of your house, something's gone horribly wrong. And that's how I feel about mocking. Again, no complaints about the technology itself, but just because they're there in the test code, there might be something wrong. I'll just use the word might just to, I use mocks and again, they're great. But for me, like this new keyword here, I think it's abuse to bring in a mocking framework because there's a strategy, there's a movement that you could do. And here's that movement. Duplicate the method, right? I kind of want to aim for getting rid of that new bar there. And what can we do now is I'm going to make a parameter here. Remember that public void bar everyone else is referring to, but now I have this method that no one's referring to. Why don't I inject in that particular bar? Great. Now what I could do is remove that and assign it. Then what I could do is I could clear out the old one. There it is. And what I could do is refer to the new bar over here. Now, what did I win? Testability is what I won. Did I win on coverage? Nah, maybe not, right? Probably get a 70-30 here. But I did gain on something, and I did gain on testability here. The new was kind of like swept away up there. I'll leave that one alone. That one would be kind of hard to test, but I don't care. It's really kind of like super lightweight, and I could see what it is, and it's probably not going to be that great of a source of bugs. But I am able to test that secondary bar method, and I could inject in a bar, and now I probably would need a mock, but just a regular mock. I wouldn't need any kind of like that kind of like power mock, addition. So it would be a lot leaner than if you used, the new override or whatever it is that you need. That new method is now easy to test, okay? Perform refactoring, clean it up, and that's a nice little maneuver there, all right? So next one, parameterize a method to overcome static calls. I used to say, out of ignorance, I hate static, I'll never use them again. Because I would just have a hard time, and I was trying really, really, really hard and being a good programmer and trying to, do everything test-driven development. And then I got stuck with this. And I was like, I hate you, static. I hate you. And then I would just run to my room and close the door and shut it and play my music. No, I didn't do that. But it was aggravating. And then I realized not all statics are the same. Math.max is fine, right? And I don't need to do any kind of extensive power mock or try to find a way around, mocking it or making it testable. And I realized, it's the static that is within the JVM, right? Math.max is just determining the max number between two numbers, right? This one, on the other hand, what used to plague me was back in J2EE when I was trying to do testing. We used to have JNDI. Some of you may have heard of JNDI. If you're using older technologies. Some of you know JNDI during the Log4j shell vulnerability. That vulnerability was based on JNDI, Java Naming Directory Interfaces. But the idea there was you had a static method. You had called initial context and you had .lookup. And that would always be like, how do I test this? This static thing just drives me nuts. I didn't know at the time. Let's see how you could get around that without like that power mock stuff, right? Same thing, parameterized method, make a copy. Delicious, right? Now, again, that server.getResource is the thing that's causing me heartache because that's going across the network, right? That makes the testing hard, okay? Now what do? Include a parameter. Server get resource is if you give me a string, I'll give you a resource. What is that? Well, we think abstractly, it is give me a string and I'll give you a resource, right? That's a function. And so I could extract the function from there, okay? And now what I could do is this. Bring in f.apply. Now I could get the, but again, this signature right up here, everyone's reliant on. But what I could do here now is bring a lambda over. Give me a string, give me a resource. But now this is very general. Do I even need a mock on this one? No. That's beautiful because it is a function. So if I'm writing a test for this bar, I just include a function, okay? Now, this caveat here says you don't have to do a parameter. You could do it as a field, okay? So, but let's take a look at a parameterized method. I stole this one from Ken Cousin. You could tell him about it. Anyway, so what we have here, and this is from his book. Let me sell his book. You know, that's the least I could do. Mockito Made Clear by Ken Cousin, and it's on Pragmatic Programmer. So again, if you want to use Mockito, go ahead and use Mockito. But do you need Mockito? Maybe not. Okay. This one is a biography service or a bio service here, which is I want to go to Wikipedia and extract bios for people. Okay, so I'll have some page names here, but right over here, this is going over to Wikipedia. This is making a call over the wire, and this is the way it looks, right? It's a static call as well, and pretend I'm making a network call here, even though I'm returning lorem ipsum, whatever, okay? Like, how do I get around that? Well, let me use the blob in IntelliJ, one of my favorite features. The blob is, you can kind of see what's happening here, right? We used IntelliJ before. And I'll call it duplicate here and format the code. Now I have two duplicates here. And then what I'm going to do right over here is let's go ahead and do something. What was I going to do? I'm in the wrong place. Let's come in here and replace this one with a lambda. There it is, and I'm going to go ahead and highlight this right over here and come into my refactoring. Everyone okay? I'm just doing that maneuver there. Duplicate the method. And right over here, here is create a functional parameter, okay? Which is called function. And there we go. Cool, right? So that was a nice little maneuver there, right? Control-T or Control-Alt-Shift-T. Extract a functional parameter. It did that for me. And then what I can do over here is just come in over here and just say, hey, call get bios. Oh, look at that. Thank you, AI. And call it with that. Okay? Something's wrong here. Not sure what. What's that? Oh, it needs a return probably. There we go. Nice. That was a neat maneuver. Right? Okay. Oh, hello. Okay, you could probably clean a few things up here. You can make that one a method reference. You can make that one a method reference. Okay, and there we go. Now, if I ask you this now, what is testable? Get bios is testable. Because what I could do then is for the injection part here, I could just inject in a function that if you give me a string, I'll return in a fake string. That makes it highly testable. It kind of shoves all the staticky stuff elsewhere, makes it a function. I think overall, I think you'll be very pleased with that. Yeah?
If I want to see the function applying that to an exception, how would you handle that?
All right, good night, everyone. So, yeah, exceptions are always a interesting thing, particularly when you have functions. There are some functions where you can handle that like internally inside of the apply, but you could also bubble up those exceptions as well outside of the method. The reason why that's another interesting question is I've been using error types in my programming, which is take a look at like the Vavr library as well. So if something is going to throw an exception, I'll wrap things up in a try, an option. You've seen option before, so if something fails, I'll have a type that represents that particular failure. So I've been programming kind of like that. But let's classic Java it. If I have to throw an exception in that function, I could do a try catch within there, send that out to a logging, or bubble it up so that way I can track it out elsewhere. Okay?
So if you have a throws exception for get BIOS, that wouldn't cover it, right? You would have to do it within the function apply.
I think so. You're saying just because of the signature? Yep, that's true. I might want to consider a different signature for the error handling if that was the case. Correct. Yep. All right. Beautiful. Excellent questions. Parameterized constructor. So constructors are not actually a part of the interface. They're just constructors. Okay. So you could do a lot within the particular constructor. Let's take a look at this one. Public class foo. Again, there's that new in there. And the smell is it's inside of the constructor. What do we do then? So let's copy it. Okay, here it is. Same thing. Now move things to wherever they need be, and I could call this with new.bar. Can I test that top one? No. But I could test the second one. I can make it protected for testing purposes. Okay? Now, one of the things that you could do is you could also annotate it as deprecated as well, and take it easy that way, right? Hey, don't use this one anymore. Just because we called a new keyword on there, use this instead, okay? So, great. And you could use lambdas for that. How do we do that? Where's the constructor here? Well, it's the default constructor. You get one whether you want it or not. So make 2 copies of those, okay? And then what you could do is you could bring that in as part of the constructor, as part of the function, make a member variable, and same sort of thing again, okay? That server.getResource then, we can replace that with that function from there. This would be great if you're multi-using that one particular function, so therefore you want that as a member variable, okay? But you can go about it that way as well. And so if you want to deprecate this one just because you have a static method that makes a network call, I'm in agreement with that because a constructor to me should never be going out to the network anyway, so deprecate that. Nice. Now, what happens if you want to affect change to code and the code already exists? How do you go about doing that? Well, what you could do is you could do what's called a sprout method, which is the following. I know I want to affect a behavior within this method, so what I'm going to do is I'm going to pretend there is a method, and it's called Baz, and it's going to be in a comment. Sorry if the screen's too bright here. What you're seeing between that bar and do something is a commented out method called Baz, okay? This is where I want to affect a change. I could add variables, local variables to it if I want to. I could return something from it, but this is me adding a change to this. Now I could refactor afterwards, but I know inevitably I want to create this new method and it should be in that original class. And so therefore I'm going to create that Baz. Again, TDD is not only for greenfield projects, but also older projects that have been in place. You're adding new functionality to it. Use test-driven development. Nothing wrong with doing that, okay? When everything has been tested and it's realized and it's come to fruition, what you can then do is uncomment that new block, and if you need to do any kind of additional refactoring, go ahead and do so. And that's what the sprout method is. You're sprouting new methods in that class. There's also another one called sprout class. The previous one we just did a method. This one's called a sprout class. The idea for a sprout class is the same thing. I want to affect a change inside of this bar. I want to add other functionality. I did decide to put this in the original class and not use an adapter pattern for it. But here's an example of that, right? I have this class called other with a Baz method on it. I'm going to use comments for that. Then I will go about creating that class with the signatures, okay? defining whatever it is that they're going to be returning. Make sure I add that call there. But the big part of this is do test-driven development again. You now are creating a brand new class that will interact with it. Go about it using TDD and do things the right way. And then whenever you're ready, just go ahead and uncomment that out. And now you've just sprouted some new classes there. Okay? Let's take a look at that one. And I'll just go this one, do this one kind of light here. Like this is a blackjack, and I have a wallet in here already. So one of the things is, when the game is busted, when the dealer went bust, when one hand beats another, or the dealer this time pushes against another, or we lost to the dealer, right? One of the things that I could do with this is I could say, here's a wallet in here, right? And say, let me kind of expand that here a bit so everyone can see that I could just say the following. Here's that new wallet here, right? It would make sense to sprout things in here. If the player busted, depending on whatever the bet was, I'll have a wallet in here and, call it deduct funds or whatever, right? Because the player lost in this case, and whatever the bet was, right? Obviously, I would need some sort of bet in here, whatever was bet, okay? And if I want to sprout this one, wallet, I'd have to deduct the funds off of that one as well. And so what I'm doing in here is, I'm sprouting this one in. Deduct funds, right? And that's the idea for that. TDD, the wallet, make sure it'll work, and then whenever I'm ready, I'll go ahead and turn that on within the code. Then afterwards, refactor so that way you're pleased with it, maybe even dependency injection a new wallet or however it is that you want to go about doing that, right? That's what the sprout is for. Groovy. Now, one of my favorites in here, wrap class and method. Let's talk about the wrap method. Wrap method is this one. Identify a method that you want to quote unquote change. I want you, or let's say someone comes over and says, I want you to make a change to this code. And you're like, okay, I'm going to destroy my code, right? But you don't want to do that. You want to take a deep breath, relax a bit, and think things through. So the wrap method is this. Rename the method and then create a new method with the same name and signature, okay? Remember, your users are still reliant on that signature, and you don't want to mess them up. But again, you're just moving the furniture around. So so here's the old one up here. I'm going to call it deposit TX as a rename. This one's empty, what you see here in red. Then I could place a call to the old method in the new method. Again, we're just routing things. You see how this feels like surgery, right? Just moving things around, okay? Then what we could do for that deposit is have our audit in here, right? We wanted audit. Maybe we want to send to Kafka. Maybe we just want to output that in a log or whatever, right? And that's what our audit is. But at this point here, we can do a TDD on this particular audit here. Okay, it's a new method that we are adding, and we can add that responsibly. So that's one strategy to adding code that adding code to code that already exists. Here's another strategy, wrap method number 2. Wrap method number 2 is identify a method that you would like to change. In this case, what you would have is you would have your audit method. Go ahead and develop that. Use the TDD for that. Again, don't pile bad code on bad code. Start to pay up on creating good code and well-tested code. And what you can then have now is 2 different flavors of a deposit. Most of the users are going to be relying on the first method up over here. But now what we have is we have an audited deposit as well. So you give your end users a choice. Which one would you like to use? You want to use the audited one, or do you want to use the regular one? Okay, nice choices there. But the delicious one, wrap class. Wrap class is, again, I want to add auditing to this particular deposit. Identify the method you would like to change. Ooh, here we go. Extract the interface. Oh, now we're getting there. Look at that. Extract the interface from this. Now, in this case, I extracted the interface. I call it bank. The original bank is now called bank impl or bank original, bank standard, whatever you want to call it. That will implement that bank and have the deposit there. Okay? Now what I'm doing is I'm putting something, in front of everyone saying use this instead, and now we could swap things out, right? That's what an interface is. And now what I'll have here is I'll have a bank logger associated with this. Great. Okay? Bank logger, deposit. Okay? And deposit is the method that's part of the interface. But notice in here, this bank logger, take a look what's in the constructor. Bank. Okay? It's going to be an important part here. Because what we're doing is we're kind of essentially doing this kind of onion thing to it with the same interface. That's important here. So I could bring in for this logger here the auditing features that I needed to add. But in this case here, right, open-close principle, I'm adding features without changing the original whatsoever, right? And that's the best part about this. So I'll bring in the audit now, do TDD on it, beautiful, add new work or behavior to it, and then what I could do then is have the following. Have the audit, and remember this bank that we're talking about here is coming in the constructor. So again, we're onioning these behaviors together. Beautiful, okay? And if you take the UML of what you had just done, you end up with a design pattern called the decorator pattern. And the decorator pattern is absolutely great for these sort of things. Again, think about leaving your original code alone for things like logging, auditing, maybe observability or other features to it, because your core is going to be your domain stuff, right? But all the others are more infrastructural, right? So you can wrap things around it. Okay? Let's talk about some other cool features that you can do for this. One is introduce a instance delegator. If you feel like you created a static erroneously or someone else did, you can introduce an instance delegator in this case. This is how you undo a static in a more responsible way. Create another method that is going to be instance-based, and then what you could do is call the static method from that instance. Okay? Now you have that, deprecate the old one, and or just go ahead and go on the hunt there and find locations where that static call is being made. Cool, right? That's a neat little technique. And so there it is. Change everything to the instance. Another thing you could do, particularly if you're on a code base that you're trying to understand, throw nulls at it and watch it blow up, right? But learn a lot from it, right? And so that's a pretty cool technique that you could use. Subclass and override, what's this technique? This technique here is let's say you have this method here, call web service. It's going to make a call to some bank and get the latest interest rate, and it's going to return that interest rate. It's a network call, right? But I'm trying to create a unit test out of this. What do I do? So if this is the case, I know Venkat likes to use this one quite a bit. And one is make it overridable. So if it's final, get rid of that final. It doesn't really affect the interface if you change that. Adjust the visibility, maybe to something like protected, so you could use it in a test. And then what you could do is you could extend it. And what you could do then is override that web service and create just a fake value when you return that. Okay? That makes it testable. That's a really nice way to go about it. You could also override this as a test. So you can create a test that extends or implements that interest rate calc. And in your override, you could just go ahead and override that fake value. So if you've got a method that's making a network call, there's a way around it. Okay? And that's a really cool technique. Sensing variables. Let's jump right into this one. What does this code do? I don't know. But let's say in this case you think it has something to do with a tax based on certain dates. And one of the things you see here, I call it the inverted pyramid, when you have like big chunks of code and there's a bunch of white space there on the left-hand side. How do you figure that out? Like, what is this code doing? Well, one of the things you could do is create public member variables and just have like little triggers on there. And then put these markers elsewhere in your code here. Hey, it looks like the New York, Florida surcharge has been applied here. I think that's what it does. Let me just verify that. And if I want to create some testing on this, I could do so and get a better sense. No pun intended, but you get a better sense as to what your code is doing. Okay? So you could do that. Again, just figure out what is being applied here. But again, those are what are called sensing variables. So yeah, all pretty good stuff here. Let me just go ahead and finish up with some soft skills. And one is learn your IDEs very well. I love my IntelliJ immensely, right? Know your blob. Know your Control-T for refactor this. Or Control-Alt-Shift-T for Windows and Linux users. Know how to rename things, okay? Know how to move methods, extract fields, extract constructors, right? Know how to do all those and do all those very quickly. Know how to do test-driven design very quickly is another big one. I'm an IntelliJ person, and one of my favorite features is Control-Shift-T or Command-Shift-T. Know that one when it comes to test-driven development. What's that one? I just showed you there, but it was really quick. But Control-Shift-T, Command-Shift-T, jump from your test to production as fast as possible. One of the excuses I often hear is like, I don't want to do TDD. TDD is slow. And I like to be a nice person, but in the back of my brain, sometimes I'm not that nice of a person. So when they say, I don't do TDD. TDD is so slow, and the back of my brain is like, TDD isn't slow, you're slow. But I never say that, right? But all these techniques are gonna really, really save you some time, and I think you'll really enjoy that a lot. So if you're new to your IDE, or maybe you don't quite get it that well, and again, it doesn't have to be IntelliJ, just pick one, know some of the actions that are available, so that way you could speed through things. Learn how to jump from test to production quickly. A friend of mine has Testing Thursdays. I thought this was a great idea. He had a Ruby on Rails project that was generated in a hurry. They didn't, have things testable. They had things all over the place and things were ugly. So his group decided to have Testing Thursdays, which is don't create new code on Thursdays. We are going to catch up with tests, okay? Make it hurt. I'm just kidding. Scratch refactoring. One of the final parts here when it comes to scratch refactoring is branching doesn't hurt. If you want to try these now, branch, okay, right? It's cheap, it's easy, no one knows you did it. And move stuff around. Try some of these techniques, right? Fail. Learn how to fail on this a couple of times until you get it. Refactor without tests. Go ahead and do it. No one knows. Right? And so that's the part about scratch refactoring. No matter what happens, though, never merge back into the main branch, because again, that's your experiment bed. Or you know what? Create a branch and create a brown bag or something and make it interesting, make it a presentation. Hey, I saw this great presentation, and I'm going to try some of these refactorings here. Tell me what you think. And again, I'm not pushing a main branch. I just want to get some ideas, right? That's where branching comes in. And of course, lambdas will be your friend. Delete unused code as well. So, when you try these, if you have some unused code, make sure you delete those. Don't comment them either. I love that. I leave this code here just in case anyone needs it, right? They're like, all right. Okay, anyway, programming is the art of doing one thing at a time, slowly thinking about it, and I hope these features have really helped you out. Again, here's where this is based off of. I modernized it, and I hope you got a lot out of it. Thank you.